Hey, what is going on? It is Thursday, July 7th, 2022, and yeah, July is kicking along here, still in the first third, so it's still early, right? Not mid-July. And yeah, welcome to Chef, the Algo Guy. I have another problem for you today. 1064 fixed point. But before we continue on with this problem, please, as usual, like, subscribe, and comment. It helps my channel, helps the algorithm pick up my algorithms channel, and yeah, it helps me get my videos out there and motivates me to continue to hopefully help others out there, along with the several other Leetcode videos that are out in the world. So, without further ado, let's continue. The problems, 1064 fixed point. It's an easy problem, but sometimes easy problems have a way of getting you, and understanding easy problems is a foundational way to get better at the harder problems, right? So let's look at the statement. Given an array of distinct integers ARR, where R is sorted in ascending order, return the smallest index I that satisfies R of I equals I. If there's no such index, return -1. So this pirate array, I guess. Okay, so and the input is -10, -5, 0, 3, 7. The output would be 3 because 3 happens to be ARR of 3 equals 3, right? And so we see that here. This is the situation here. Now, looks like you can look at this and be like, okay, first the array is sorted in ascending order, so it's sorted and it's an array, so should think first binary search, right? But there's a little trick here, right? Here's the situation. You have ARR is 0, 2, 5, 8, 17. The answer is ARR of 0 is equal to 0. Okay, sure, that's fine. That's not so bad. And let's see, what if we have something else? Let's try this. Oh, and also, if there's no output that exists, right? If there's no situation where we have ARR of I equals I, we don't return anything. We return -1, sorry. And these are your constraints. And it also says the O of n solution is very straightforward. Can we do better? Yes, because the O of n solution is literally iterating left to right. Okay, and remember, it's a sorted array, and we can use binary search on sorted arrays of integers. Okay, so here's the first thing that we want to consider. Okay, this is the case that will trip us up. By the way, the case where ARR of I equals I is called a fixed point, okay? That's known in mathematics, f of x equals x, right? And it's asking you, this problem is asking you to find the smallest fixed point. Okay, so here's the situation. This is the tricky situation. The smallest fixed point, right? Smallest index I. In this array, you can have two fixed points. You can have 4, right? 4 is a fixed point, and 3 is a fixed point, right? So when you do your binary search, right? If you're familiar with binary search, initially you may pick up 4, right? So how do you know to pick up 3? This is the trick behind many binary search problems, like the index. This is why I find binary search kind of hard in general. Like it looks pretty straightforward and simple, but in many cases the indices can vary. So the index conditions, the search reduction, space reduction conditions can vary so much from problem to problem sometimes that there are patterns, but it can still be confusing. The logic of it can be confusing to extend to other problems. So you can't just end at 4, right? So what can you do if you find a fixed point at 4? You don't just return 4. In this case, it's asking you to return 3. So you have to continue your binary search. That's the important thing. Continue binary search even if target is found. And if you find, and basically, you still have to record the fact that you found a fixed point at 4. But you continue the binary search, and you continue to the left of 4, because at this point, you're not going to find anything. You're looking for the smallest fixed point. So even if you had a 5 here, right, and you landed at 4. There's no point, if you're continuing your binary search, to look to your right. So you can discard your array, binary search array, right? And you can discard everything to the right of 4, and you can continue to 3. You can continue searching to the left. So basically, finding a target means continuing the same search condition that you would as if you were looking for a value less than the target. Does that make sense? Let's write the code and we can point it out there. So your standard binary search, I'm going to do this iteratively, by the way. You can do this recursively. Iteratively is more memory saving. Okay, so you remember, you start at the beginning of your array and at the end of your array, and now I'm going to say val equals -1. Okay, that's what I'm going to return, right? I'm going to do return val. So the binary search, we're going to start with our standard algorithm, while start less than end. So your midpoint, right? We're calculating midpoint here. We always calculate the midpoint of our search and of our search space. Our midpoint looks like this: mid start plus n minus start is less than 2, and we do it this way to avoid integer overflow. Okay, at least in Java, because midpoint can be calculated in other ways. So now here's the thing. So let's say we have AR of mid equals mid. Okay, I'm gonna leave this for the last, but let's fill out the other conditions. Else if AR of mid is greater than mid, and you can think of mid as the target. Okay, like if you've seen other binary search problems, you know what I mean. Else if AR of mid is less than mid. So now, okay, so if AR of mid is greater than mid, right, that means that we have to shift our endpoint down, because our target is found lower in our array. Okay, so the next iteration is going to have a reduced search space by the endpoint shifted by 1. If AR mid is less than mid, then that means our target is higher in our array, so we have to start at a higher point. Now, what about if you find mid? Remember what I said, you have to continue searching to the left, right? So in this case, we record mid because we found a potential minimum fixed point candidate. But in this case, we continue to search to the left of our array. So that's why I'm replicating this condition for AR of mid is greater than mid and AR of mid is equal mid, because we're still not done searching even if we found a singular fixed point. And so what happens, let's first run this and see if this works. There you go, and run it. And there you go, it's fast. Okay, just remember here, this is the thing, is we're not landing on a singular fixed point here. That's why we're continuing the search. I could have compressed also these conditions together, right? Mid, AR of mid, and these two, because it's the same thing, so these two conditions, but it's better to elucidate and write it out for learning purposes, because you know exactly what's going on. If I just said greater than mid or less than mid, then it might occlude the fact that we're continuing the search and basically recording the fixed point. So that's it. If you like this solution, like, subscribe, comment, and yeah, have a lovely day, continue coding, and I'll see you next time.